All right, guys, so we're starting on lesson 87, and lesson 87 is going to be on page 272 if you guys are looking in your textbook along with me. It's not a very long lesson. It's not going to be very complicated, so I believe we're going to move through it pretty quickly. But lesson 87 is talking all about different properties in algebra and in pre-algebra. And we've talked a little bit back a few lessons ago. It says on lesson 84 when we went through the properties of equality, talking about the addition problem of equality and the subtraction problem, or subtraction equality, meaning that if we subtract a number on both sides, the equation doesn't change, or if we add a number on both sides, the equation doesn't change. So let me blow this back here so we can actually see it all again. But now what we're getting into with this lesson, it's all talking about the properties of different numbers. And what this all means, we'll go through them one by one so we can see what it's going to talk about. But the first one that we're coming to, if you, like I said, if you're looking at your textbook with me, it's on page 272, and that is the commutative property. And essentially, basically, all the commutative property states is that if you have A plus B, that is always going to be the same thing as B plus A. So we can put them in any order that we'd like, and it's not going to change the overall problem. And just like we can do it with addition, it can also be done with multiplication. So if we had A multiplied by B, we could switch it around and have B multiplied by A. Now this will only work with addition and, whoops, where'd it go? This will only work with addition and multiplication. We won't be able to do this with subtraction or division. But for addition and multiplication, this works really well. So if we clean our board off here, to give us a real world problem, what this would look like, if we had 2 plus 5, for an example here, we know that 2 plus 5 equals 7. With the commutative properties rule, we can all switch this around and we can write 5 plus 2 equals 7, and our problems would still be true. So we can put the addition part in either order that we would like, and our answer is not going to change. Likewise, if we have 2 multiplied by 5, we know we get 10. We can also switch these around and have 5 multiplied by 2 to get 10. So for addition and multiplication, we can put our numbers in either order and our answer will be the same. That is going to be the commutative properties rule. So if we clear this off here, the next one that we go to at the bottom of the page that you'll see is called the associative property. Now what this one means is that if we have 2 or more numbers, again, these will only work when they're added or they're multiplied. We can group, or it says we can associate any 2 numbers first before we do the other ones. What that means is that if we have, let's say, 2 plus 3 plus 4. If we run this out, we know 2 plus 3 plus 4 is going to give us 9. But we can say, well, let's multiply, whoops. We can say, well, let's multiply, or add 2 plus 3 to get 5, and then 5 plus 4 to get 9. So here we worked left to right. We did 2 plus 3 first, and then we added our leftover number here. We can also say, okay, well, let's start with the 3 and the 4. 3 plus 4 is going to be 7. 2 plus 7 is going to equal 9. So with the associative property, we can associate any 2 numbers first before we do the other number. Now, again, this only works with addition and multiplication. We are not able to do this with subtraction and division. So if we keep our numbers here, and if we do 2 multiplied by 3 multiplied by 4, we can say, okay, 2 times 3 equals 6, and 6 times 4 equals 24. So here we did the 2 and the 3 first, and then we multiplied our answer by the 4. We can also group these in the other order. We can say 3 times 4. So it's up to us whichever ones we want to do first in these cases. 3 times 4 is 12, and 2 multiplied by 12 would equal 24. What this looks like if we wrote it out with variables just to go see, so we can see what we're doing, is A plus B plus C would be the same thing as A plus B plus C. So here we can add A and B before we add C, or we can add B and C before we add A. As long as we add them up with the associative property, it doesn't matter what order or which numbers we add to which numbers, as long as they're all addition or they're all multiplication. Same way we could have A multiplied by B multiplied by C would be the same thing as multiplying B times C and then multiplying it by A. So whichever two we want to multiply first, in this case, we will get the same answer at the end. Now, the little tiny box at the bottom of page 272, it's going to be our shortest one, but since it's in here, we are going to touch on it. The reflexive property essentially states that one number is going to be equal to that same number. It's just an obvious fact that a number is equal to itself. So it's just to tell us that if we have 5, that is going to be equal to 5 to make it true. 2 cannot equal 7. 2 is equal to 2. So the reflexive property states that one number is equal to itself. Moving forward, we only have 2 more to touch on. The next one is the symmetric property, and that means that when we change, we are allowed to change the order of any equation, and it's going to be still the same answer no matter how it's written. Usually it's to help us get a variable on one side or the other. So if we have, from our example in the book, 10 equals x, the symmetric property allows us, I keep moving the screen over, I apologize. There we go. The symmetric property allows us to just switch these on different places. So we can write x equals 10, or we can write 10 equals x. If we move everything to the other side of the equal sign, it's not going to change our equation. So we could write 2 plus 3 equals 5, or we can write 5 equals 2 plus 3. How this would come to help us in an actual problem, because I know we had questions about this actually in the last class on Tuesday, is that if we have a problem that says y equals 2 plus 3, for example, we know that 2 plus 3 is 5, so y, whoops, here we go, y is going to equal 5. But we can switch this around if we want them to be on opposite sides. We can say 2 plus 3 equals y, and our equation is going to be the same. Doesn't change the problem, it just changes what numbers are on which side of the equal sign, and that's the symmetrical property. Just because it makes things symmetric and it's symmetry, they're going to be the same. So here we would still have y equals 5. Okay, and our last property here for algebra is the transitive property. And it means, and just reading from the book, that two things are equal to the same thing. Now, what that means is that if we have, let's say we have a number for A. If A equals B and B equals C, then C is equal to A. We can conclude that C is equal to A because we know that A is the same thing as B. B is the same thing as C, so A and C are also going to be the same number value. How it would read in a problem on page 273, we see it in our book right above transitive property. It says if Steve and Sherry are the same age, and Sherry and Brooke are the same age, it is correct to conclude that Steve and Brooke are also the same age. Now, going over there, we might say, well, aside from just helping us in simple problems, when we would actually have to use this in our math book and what kind of problems would we have to work these in? Well, example 1 in textbook on page 273, it says use the commutative property and associative property to simplify this problem. And I'm going to go ahead and write it on the whiteboard here. So it's 87 plus 49 plus 13 plus 51. So if you remember, the commutative property means that we can add any two numbers or that we can switch these numbers around in any order and it's not going to change our answer. Just because they're written in this order from left to right, we do not have to keep them in this order from left to right. And the associative property means that we can add any two numbers together in any order that we would like as long as they're all addition or multiplication. So in this case, we could move left to right and we would get the same answer, but by looking at these numbers, we can say, okay, well, it's a whole lot easier to add 87 and 13 because we have a 3 and a 7 on the end, so we know it's going to come out to an equal 10. So 87 plus 13 is 100. And we know that we can 49 and 51, we can add together a lot easier because 49 and 51 would come out to 100. 100 plus 100 equals 200. So using the commutative property and the associative property, it makes working this equation a whole lot faster than moving left to right and saying 87 plus 49. And then we have to add it in, bring the one over and add it all together. Here, it's much easier to add these together using that property.